Let's talk about a data structure called NumPy arrays. NumPy arrays are very similar to lists. However, there's a lot of behind-the-scene optimizations for NumPy arrays. So developers has made significant effort to improve Python lists, turn them into NumPy arrays, so that when you are doing scientific computing data analytics, manipulating numbers stored in NumPy arrays will be much more efficient. In order to use NumPy arrays, the first thing is to import the NumPy library in Python. We can import NumPy, but a convention is to give it an alias, which is called NP. So then we can start to create and use NumPy arrays after this importing command. So here, let's try to create a NumPy array to represent a list of customer ratings. Right? Let's say you're running a business, you collect ratings from the internet. Now you have collected 5 ratings on a scale of 0 to 10. And let's just start with the first NumPy array. So let's give it a name, right? So let's call it just ratings. Then I want to create an array which is a list of ratings. So let's first do a list. 3, 4, 5, 6, 7. Let's say we happen to have 5 rating numbers from 3 to 7 out of 10. Now if I get the list, I can apply this command np.array and takes the list as the import argument. And this will help me create a NumPy array called ratings. And let's just return the content of ratings by including its name in the end of a cell, and then run it. As expected, it gives us an array with 5 elements: 3, 4, 5, 6, 7. If we already have an array, there's important attribute called shape. For this array we have just defined, let's get the shape attribute from the NumPy array ratings we just created. To do that, we just need to use the name of the array, then dot the attribute called shape. Run it and see what happens. As we can see, it tells us that the first number of the shape is 5. That means exactly that this array has 5 elements, right? 5 numbers. And there's a comma, but nothing following the comma. If you see an individual number, a single number, and then a comma and then nothing, this basically means that we have a one-dimensional array. And what matters is just that how many elements do we have in that one-dimensional array. There's a concept called axis. If you move along the axis, you are actually enumerating over the elements included in that array. Now, we have seen a one-dimensional array that's typically just something like a list of numbers or list of strings. Typically for NumPy array, usually we deal with numbers. But we can also have two-dimensional arrays. For two-dimensional arrays, each element of a two-dimensional array will be a one-dimensional array. Now, for example, here we want to create a two-dimensional array that includes 3 elements. Each element will be, let's do actually 2 elements. Each element will be a list or a one-dimensional array of 5 items. So let's do this. Let's create an array which is called ratings 2D. Okay, and then to construct this two-dimensional array, we're gonna do 2 lists. let's say the first list is 3, 4, 5, 6, 7. And then the second is 5, 7, 5, 9, and 10. Well, we have two lists, right? And then I'm gonna put those two lists between square brackets. That means we have a list of two lists, right? Each element of that list is another list. So we have two elements, each being a list. Now I'm gonna apply this NumPy function, np.array, taking the list of two lists as an argument. What we get, so let's again include the name of the array we just defined in the end of a code cell. What we get is a two-dimensional array, right? Something like a table. As we can see here, we have two rows, and each row has 5 columns, right? That's something we call a two-dimensional array. So for two-dimensional arrays, we actually have two axes. Right? One is to go from the first row and moving down to visit the subsequent rows, and the other direction will be going from left to right. That means for any element as a list, as a one-dimensional array, we go from left to right. We're going to enumerate over the elements of a single component, a single member of the two-dimensional array, right? Each single member of the two-dimensional array is just a one-dimensional array. Okay, so then we can get the length and shape of the two-dimensional array we just defined. So the array we just defined is called ratings 2D. If I apply the length function, we should be able to get the length, which is the number of rows, right? Because we have two elements, each being a one-dimensional array. That means we have the length of the two-dimensional array being 2. Let's do also shape, ratings 2D dot shape. This time we got 2 and 5, right? It means that this two-dimensional array has a shape of 2 by 5, 2 rows and 5 columns. Now, if we have an array, we can perform mathematical operations and calculate statistics from the given array. Right? So let's go back to the one-dimensional array ratings. Let's display it again, 3, 4, 5, 6, 7. One thing we can do is to do multiplication. Let's say multiply this array by the single number 2. Right? What it gives us is every element of the array being multiplied by 2. So basically, if you multiply or do any other mathematical operation with a single number, the outcome will be an element-wise operation. Similarly, ratings. Then this time, let's do a power function, right? 2 stars represent a power operation. Let's raise every single number in the array to the power of 2, right? The square all the individual numbers. So if we'll get 9, which is the square of 3, and square of 4 is 16, so on and so forth. That's one thing we can do. We can also calculate some aggregate statistics, the rating array, and then one thing we can do is to do ratings.sum, and that will give me the summation of all the numbers in this array. Right? 3 plus 4 plus 5 plus 6 plus 7 will be 25. Okay, so we can also do ratings, the name of the array dot max. That will give me the maximum number in this array. Or we can change math to minimum. That will give me 3, the smallest number. Right? We can do mean value ratings dot mean. That gives me the average among those 5 numbers. Or we can do ratings dot standard deviation, and that gives me this number, right? That's gonna be the average deviation of those 5 numbers from the mean value. Okay? So we call them aggregate statistics because we take an array of numbers and convert them into a single value. It can be mean, summation, minimum, maximum, standard deviation. We have done this for this one-dimensional array, but things are pretty much the same for two-dimensional or even higher dimensional arrays. One thing useful is to construct evenly spaced numbers. So this is fairly similar to a function we have seen before. There's a function called range. Actually, that's also a data structure. Right? A range is a set of evenly spaced numbers. Let's say range from 1 to 10. That's going to be 1, 2, 3, 4 until number 9, right? Not including 10. And then the NumPy has a function called arrange, which is very similar. We can do, let's say, from 2 to 9. That will give me 2, 3, 4, 5, 6, 7, 8, not including 9. And let's take a look. Right? Of course, the outcome is going to be an array instead of a regular list. But one thing being useful is that I don't have to confine myself to whole numbers, right? So let's do one thing. Let's say step equal to 0.5. Then this time I still go from 2 all the way to 9, but I don't want to include 9. Right? If I specify step equal to 0.5, so every number is going to be 0.5 larger than the previous number. Right? That's the idea of having a step size. So this is a bit more general than the range data structure before we introduced the NumPy. Okay, so np.arrange, another example. If we're starting from 0, let's say 0 from 0 to 10, right? It's actually 0 to 9, not including 10. 0 can be omitted. If we drop 0, just include 10. Then it will just start from 0. Another way to generate a list, or actually an array of evenly spaced numbers, is to use the linspace function. It's quite similar, but there's one fundamental difference. Let's take a look. Linspace from, let's say, 10 to 20. It will give me it should be np.linspace, right? It gives me a lot of numbers. Actually, if you count the number of values here, you will find that by default we get 50 values, starting from 10, ending with 20, right? So basically, I specify a range from 10 to 20, and then I will get a total of 50 values between 20 and 20, 10 and 20, including the two starting and ending numbers. Right. Of course, we don't have to use the default number. We can do np.linspace. This time, again, 10 to 20. But this time, let's say I only want to get 5 values. So it will give me 5 values starting from 10, ending with 20. And later on, we'll see this is particularly useful if we want to generate a visualization like a line chart and other things. Okay, so maybe one final example, np.linspace. We can do from 10 to 20, this time with 10 values, right, from 10 to 20. The difference from np.arrange is that in this linspace function, we specify how many values we want to get. In the np.arrange function, we don't specify how many values we want to get. Instead, we can specify the step size, right? Starting from the first number, I take a small step to get to the second number, and then another step to get to the third number, but how large is the step?